Welcome everybody. Very awesome to see everybody here who are the real diehards, the people staying to the last moment and being pushed even more about security. I really applaud you all that you can take in much more information at the last moment. Well, so I'm here going to talk about the SKF Keeper project. There is no right or wrong, there's only fun and boring. So my question first to you all, to get you a bit awake, does somebody recognize this quote? No? All right. So I grew up loving hackers, and this was actually from the movie The Hackers from the 90s, where you had the evil guy, the plague, and this was his quote actually. So, just a quick introduction. Who am I? I am Cate. I used to play a lot of games, Unreal Tournament, Amiga 500, and all that good stuff. And actually, then I thought, gaming is awesome, but well, it's actually code. Let's see if we can actually reverse engineer the engine of Unreal Tournament and see if we can do cool stuff with it. So that's what I did when I was like 13 years old. So that's more than 20 years ago. Built some aimbots, and from there I was really hooked about programming and security. So here I built an aimbot that automatically aimed on my opponent's head, and then well, it popped some heads. Nickname Mr. Headshot. Really awesome times. Now fast forward 20 years, I'm actually working at ING, security chapter leader there, responsible for penetration testing, code reviewing, making sure that the skills of the people in my team are improved and all that good stuff. Also, what I want to show you all here today is that, as every big company, we have really a lot of challenges nowadays, right? Similar like we also have them and had them at ING. And, well, what I like to call the challenge of SEC DevOps. I mean, we talk a lot about DevOps and Agile, quick release cycles, super awesome. But how do you fit in security when you're releasing, I don't know, 10 or 50 times a day? For example, if you look at all the other type of tooling that are out there, right, and a proper secure software development lifecycle with the most, components that adds the most value. You look at the security requirements, for example. I notice a lot of companies actually don't really have those. That's more like a best effort approach, right? Then when we also look at quality of software, a lot of companies don't even define what is actually a good quality product for us. As you know, you have like the ISO 25010 standard that has the 8 pillars that define in totality then the quality and the level of quality of your product, like code quality, end-to-end testing, performance, etc., which security is also one part of it. But as you see, they all tie together, right? Because if you have like code complexity or dead-end code or, well, all that good jazz, then that will also introduce security vulnerabilities. And especially for complexity of code, because that's where actually all the logical vulnerabilities will sneak in, right? And that's very hard and very bad as well, because there is no security tool that actually can find those vulnerabilities. So pretty bad, I would say. Well, then when we talk about the secure software development lifecycle, we have security tooling like SOS, DOST, and EOST, and software component analysis, of course. And then you have the manual verification, where you do regular penetration tests, code reviews, and all that good stuff. So when I talk about SOS, so what do we actually mean? So these are static code analyzing tools, right? So you have them in different flavors. For example, the Fortify checkmarks, they really go into a sort of taint analysis mode, where you have the user input and it is being tracked over the code and over the different functions it's being used, and then verify, hey, if there was applied any encoding, escaping, and so on. And if not, then you have a vulnerability. Now, the other ones, for example, the OWASP dependency checker, so this is more a software component analysis tool, right? So it will only look, hey, which type of libraries I'm including in my Java project, and which version is that, and then checks with an open source database to verify, hey, is there any vulnerabilities or known CVEs in this library that you're using? Also very important that we do those type of things, but they fall under the static code reviewing, right? The static analyzing tooling. Then we also have the dynamic. So this is basically security tooling that is running against a real application, right, in a running state. So it's not looking at the source code, but it's trying really to fuzz and inject all the good stuff. Probably if you have some experience with this, then you already realize that, yeah, you know, running a DOS tool against your running application, that's awesome. But in some cases, it can run for like hours and sometimes days even, right? So again, the challenge of Sec DevOps, how do we add security in this super fast release cycle? Now, there's also another one that is, I would say, a bit more interesting and more hopeful, the EAST. So this is interactive security testing. And basically, these type of security tools, they place sensors inside the application, which they have then more context, which they then can better define and say, yeah, you really have a vulnerability here. And also you have way less false positives. So, false positives, what is that? That is actually why a lot of developers, I would say, don't really want to do security, right? It's those nasty little things that you think, oh, I have a real security vulnerability, and then you deep dive into it, and then it turns out, oh, shit. It was actually, the tool didn't have enough context, thought something was vulnerable, but then actually after putting a couple of hours into it, you realize there is no vulnerability. So those are the false positives. And we really hate them because they will take a lot of energy from us and make us do no security actually. Another great OWASP project is the benchmark project. And here is actually a subset of Java classes and Java functions, which some are very obscure built but secure. And some of the classes have actually vulnerabilities. So here we want to see and test different type of tools, right, security tools, to see how well they actually do. And well, as you can see on the picture, we hope to have some stuff in the left upper corner. That means it can find all the vulnerabilities with no false positives added to it, right? But then if we look at the the outcome of it, the left upper corner, it's really empty. There is nothing. And if you then take the average, around like 40% true positives, still including like 30% false positives, it's still a lot of work that you need to do to actually get value out of it. Now, here you see also the average of, around 25%, but this is not really the true average. Because my question to you guys is, from the logical vulnerabilities I just mentioned that cannot be found by any security tool, how much percentage that actually covers the total amount of all type of vulnerabilities? So is that like, you know, only 10% of all the vulnerabilities are logical, based on logic vulnerabilities, or is it less or more? What do you guys think? And please shout. Also the people digitally, please shout as hard as you can. So what do we think? Don't be afraid. 30%? Who says no, it's more? It has to be more or less. Indeed, it's more. It's around 50% of the vulnerabilities in applications are related to logical vulnerabilities. So even if the tools in here can find all the vulnerabilities, you still have a gap of 50%, right? But the tools are not finding 50%, they actually find 26% or 25%, and we just concluded it's around 50% that cannot be found, so actually the real statistic is even worse than this. Does it mean that I'm saying like, oh yeah, we shouldn't use these security tools? No, I'm not saying that. I'm actually going to say that you want to have these type of tools as like your safety net, as a sort of quality gate, the last thing in the whole development life cycle, that hopefully will catch here and there your stupid mistake, like today. Maybe we're going to commit after the party and we drink some beer, we're still going to do that commit. Well, you hope these type of tools will catch those type of things. But if your whole strategy is, hey, we're going to use these tools and we don't do security requirements and we don't do security training, etc., you will have a lot of vulnerabilities in your application. And what we also see, I'm doing now more than 20 years penetration testing and hacking, it is always the same stuff over and over again, right? And it's also not rocket science. Because take a vulnerability like SQL injection, yeah? I mean, you guys are developers, so please tell me, what do you need to do to prevent SQL injection? No, no prepared statements, that's wrong. Okay, no string concatenation, exactly. So that is definitely what you don't want to do, right? But what should we do? Input validation. Yeah, well, okay, you should always do input validation because from a coding point of view, you want to minimize attack surface. So if you can do input validation, length checking, and do restrictions, and also on whitelisting of characters, yeah, that will help. But that's not really the design pattern for solving SQL injection. It is using parameterized queries, guys. Come on. Right? No rocket science, very simple. But still, when we look at the OWASP top 10 and all the websites that get hacked, it's still present there, right? Because this knowledge is not there. So we over and over do penetration tests, we find these type of vulnerabilities. And you know, when we look at developers, we really look at them as the neos, right? And it's very unfair because, yeah, like here, developers and neo are awesome, right? You can freaking dodge bullets. But yeah, that's not how we want to have Neo, right? We want to actually, when you know Neo, you can actually stop bullets because he's the one. So we want to provide actually options how we can spread this knowledge, this security knowledge and these design patterns to developers to build applications secure by design. And you know, that's also really the challenge because if you also look at all the professionals out there, there's a huge gap. I mean, and nowadays in the development world, there's also a gap and people, it's hard to get good people. But also in the security world, we don't have enough security guys who can actually help and prevent these bad guys, right? So we really want to help developers to create skills for them to actually fight back and make a chance. So what we actually did is we created a new module inside the security knowledge framework. And this module gives you the opportunity to do a sort of self-learning of important knowledge about or secure development or offensive security, like, hey, how do I even test web API-related type of vulnerabilities or flaws? We also have a deck, for example, for Infra and Ops, because that's also important to understand why firewalling is so important, why patching is important, etc. And the cool thing is that these courses, you can just go to the website and you can start doing them. And how it's actually structured with different levels, so you can start with the easy beginning level and then work your way up. And how these labs actually work is that you first get like material, videos, content, quizzes, and after that you get a hands-on lab where you actually can practice what you just learned. So it's not only learning through reading books, right? But actually getting your hands dirty and doing the offensive stuff, trying to do that SQL injection. And then when you've done it, you know how attackers also would do it, then you are going to implement a defense. And after you implemented the defense, then you can actually see if you properly implemented it. So here, for example, is the overview of how the content would look like, and you can scroll through it. You have the different topics that are important. And yeah, you know, we already, as ING, we struggle with the same issues. There is information out there about how to do it and how to develop securely, but it's very fragmented and everywhere. And also at ING, we want to really build, you know, secure applications because, as you know, we are a bank. So that means we need to invest in our people, in our developers, and really, you know, share that knowledge with them. So we also realize that this is indeed not only a problem or a challenge that we have at our company, right? We see this over and over with also our partners, with others, and another company. So we really wanted to help society and companies worldwide to, well, at least give them a free, fully free capability and knowledge and platform where they can train and do this stuff. And, when we also look at, who's actually involved? Well, like I said, so ING, the company I work for, the OWASP community, hopefully you all know that also already, who that is in terms of an organization. Then we have the new organization OpenSSF, and they're all aligned with the same goal to educate and provide this free education tools and projects to the people who are willing to increase their maturity level. And what is also nice to actually see that we, in the MVP and the project that I have now in the current phase, we also put a chef cook and ask him to follow the whole courses. So this chef cook, he first did a course of like 1.5 years in programming and application development. And after that, he spent around a half year really consuming all the material that we have in the platform. And actually after that, I did an assessment and I concluded that this guy is now ready to start in my own team as a junior pen tester. So this is really awesome that actually, with this case, we already have like a new internal member in my team who is now part of, the whole pen test work actually. So what I also want to do is just to give you a demo of the security knowledge framework and see actually how it would work. So let me go here. And like I said, so because everything is open source, so the idea is we will have this always up and running as good as we can on this URL, and this platform is available for everybody to just log in, create an account and use it. But if you say like, actually I want a dedicated instance for myself, well, you can just pull it from the GitHub. Everything that I will show you, demo and display is in that repository, right? So you can also spin up your own instance in your on-prem environment. So the security knowledge framework has a couple of things. First, it is one place where you have all the knowledge and information that you need. So there's no need again to go to Stack Overflow or that type of stuff when you are looking for security information. So we have, for example, code snippet and code examples in different type of languages like ASP, Java, Node.js, PHP, whatever. The other thing, like I mentioned, it's super key important that you use security requirements. Because if you look at the ASVS, the Application Security Verification Standard, it contains 280 security requirements. Now I'm talking about critical applications, right? That you should apply those. Well, even me, working for more than 20 years in security and also coder, whatever, I don't know the 290 by heart, right? I need a structural way and a method to always making sure that I include the right requirements. So what we also did in SKF is to include those type of checklists in there that you can reference and use. But the other important thing I would say is that we also created a sort of wizard. So you can create, for example, here a project in SKF. And with that project, you can then create like, hey, I'm going to build this feature. You go to a wizard, and that wizard will basically create context for the SKF application and then say, cool, so you're going to build, I don't know, a search function. That means you only need these type of requirements from a security point of view. So instead of you printing out the whole stack with all the security requirements and you flip through them or try to search for the right ones for the feature you're building, we actually created a sort of wizard that creates context. And with the context, it will say, okay, this is what you want to achieve. So here are the security requirements. As you can see, a lot of people are playing with it. So for example, if I go to generate requirements, I actually can choose between two types of checklists. It's the ASVS for web API and it's the MASVS for mobile applications. So by default, we have these checklists already in the platform in SKF. Of course, when you say, well, we have our own security checklist or specific, I don't know, for cloud deployment or this or that, then you actually can, extend the type of checklist and security requirements and include your own, right? Your company-based security requirements. But for this case, I will go to web applications. And here I can also define the criticality of the type of application that I'm building. So if it's a simple website with no real risk, I go for the level 1, the bare minimum. But of course, if it's a sensitive or critical application, I choose the highest. So then I go to next, and here's basically the categories. So for example, if I'm going to build a search function, then I can pick here between a couple of categories that would be interesting for me, right? So for example, here, validation, sanitization, maybe some error handling. Yeah, I think that would be sufficient for a search functionality. And basically now I get a couple of questions. And my answer on these questions will generate context to then select from the 280 requirements the right ones for what I want to do. So, for example, hey, do you already have or do you want input validation requirements, for example, to prevent against parameter binding, URL redirects, etc.? Well, that sounds interesting. I'm not using a markdown or anything. Do you want to output the user supplied information in the browser? Yes, because I want to show back what we're going to show. Search. Are you using a database query? Yep. Do you gonna log sensitive data? No. No. Log protection? No. Here, centralized error handling. No, actually, I didn't have it yet in my app, so yes, I also want that one. So next. Here we can choose actually if we want to correlate these requirements to a feature we defined earlier. Maybe we want to enrich the feature that we are going to build. So we can also add these new requirements to that one. And now the idea is, so when we submit, the security knowledge framework is then going to correlate which type of knowledge base item and requirement is actually needed for you to build that search function, right? So here is now the list of requirements, security requirements that you actually should add or think about, right, when we are going to build this search function. And it's a bit similar like a file upload functionality, right? I mean, a file upload functionality, I can write that in like, I don't know, 3 minutes, right? I have the functionality to have a file upload. But yeah, it will be insecure AF because, there's so many possibilities an attacker actually can have with this, right? If you build it like that. Similar for like a search. So here we see, for example, verify the application has defense against HTTP parameter pollution attacks. Probably you never heard of it, but again, so this is why it's so important to use it like a methodology, a structure, a process that you can repeat over and over. For example, here, verify the data selection or database, use parameterized queries. Right, so this would already give you the hint, hey, you're going to do something with SQL. Indeed, like somebody said, don't concatenate your user input directly into the query, but use parameterized queries. What you also can do is click on the, click here, and you get actually like a lot of information from the CWE database from Mitre, explaining what can go wrong, but also on implementation level, what you need to think of as a developer. Then we have also here these nice clipboard thingies where you can click, it copies to your cache, and then you can paste them in your ticket system or whatever you're using to follow and add these requirements to your feature you're building. You can also remove them, export them as CSV. And also what I should tell is normally what you also want to do is use the ASVS and fine-tune it first for your organization. Because there might be security requirements here that are maybe somewhere centrally in your organization or in your application already covered, right? And you don't want to get this fatigue of requirements actually that are not really interesting. So the rule is always, if you use something like ASVS or MASVS, You first adopt it and adjust it to your organization, and then you, well, use it. And like I mentioned, you can make your own checklist here. You can modify also the ASVS and all the requirements, so it's quite easy to do that as well in the security knowledge framework. So this is one of the other things, right, what I said is, you know, it's very important to start with the right security requirements. Here, for example, you can manage all these different type of checklists and categories. So in SKF, you can all do this and customize it how you would like it. Now, the other thing that I wanted actually to show are the labs, because we started, we wanted to do a full circle of SKF, and we also wanted to teach developers actually how hackers work. How do they do an SQL injection or that good stuff? So we have a lot of labs actually with vulnerabilities, from parameter pollution to race conditions to the simple SQL injection and all that good stuff, or GraphQL vulnerabilities, which you can spin up and launch actually in the security knowledge framework and then practice your skills. So for example here, you click on start, it will give you back a URL. And what it did is actually, SKF has 2 Kubernetes clusters, one for running SKF, the app, the RabbitMQ, the Keycloak, whatever, all the, the services for running the application. And then we have a separate Kubernetes cluster, and in there we actually deploy all the vulnerable labs. We can't run them in the same because that would not be that good. But so here we have now a fully working, functioning application that we can test and find the vulnerability. And as you see, the lab is very simple because we didn't want to have a lot of a lot of extra code. We really want to focus on the vulnerability itself or the vulnerable function, right? To teach about security. Now also, especially when you are new to offensive security, you probably want to have some help. So we also created for all of the labs write-ups. Currently, we actually have Python, Java, and Node.js as labs environments. And when you click on one of them, you actually get the explanation. So how do you find these type of things? What is it for vulnerability? How do you then find them? The reconnaissance. And then the exploitation phase, where actually step by step is explained how an attacker would, abuse this type of vulnerability. Which then you also learn about, okay, when I build these type of functions, I know they work like this, and also when you build it, you can use the same knowledge to also do a quick sort of verification, right, before you put it into the CI/CD pipeline. So basically here we can just download and reach any file from the system using a local file inclusion vulnerability. We can do a denial of service by reading def/random, for example. So you can do a lot of fun stuff with this. So the labs are really cool, but like I said, the new thing that we did with ING, OpenSSF, OWASP is really created an awesome training platform. So here we go even a step further. I will click Secure Development, Start Training, and here you will see the Secure Software Development Fundamentals. So this is an open source training material created by David Wheeler, which you can follow and all the steps and all the categories. So also here we have input validation, and we have also one topic specifically for like SQL and writing SQL queries, etc. So the idea is that you can really go over it, read it in depth, understand all the design patterns and mitigations that they will discuss in this material. And then, for example, when we go to another topic, you see there's also the possibility that a YouTube video can be played. Also, all this, again, it's Markdown based, it's YAML, so if you want to add your own contributions to it, it's very easy to do. We have also like questionnaires in it, so maybe let's do one. I hope it's readable. Yeah, perfect, sort of. So here we have a piece of index HTML, and here we have a vulnerable piece of code. So what do we think? What can go wrong here? Is it the cross-site scripting? Who thinks it's cross-site scripting? Can I see a hand? Okay, no, well, it is no cross-site scripting because, as you know, normally template engines, like front-end template engines, they use contextualized encoding. So that means that no matter where you use the variable, the user input, because the template engine has context and they do contextualized encoding, you normally shouldn't have any cross-site scripting vulnerabilities anymore. But actually what is here the problem is the client-side template injection that you can do. So if we inject template, regular expressions, syntax into the user input, we can actually utilize the expression language of that template engine to again read configuration files, secrets. We can even, in some cases, execute functions in the template engine using the expression language that's available then. So it's pretty nasty stuff. And again, so here you get the example and like, oh, hey, here's also a lab that you can look at. It has this vulnerability. Now, when we go through all these type of things, then at the end, you will see start lab. So what we did here is basically we built like a whole complete lab environment in the browser where you can safely practice and try to hack it, try to fix it without the need to install all type of tools. So because this is DevFox, we're going to click the Java one. So now again, it's going to deploy a box into the Kubernetes stack. In the Kubernetes cluster, it will give back the environment, and boom, I have now a fully working operating system ready at hands in my browser, right? So from here, I can just go, you name it, and what is it? It's an old version of Ubuntu. You see, so we have a fully operating system now running in the browser. It's using the Apache Guacamole stack to do this, and we can actually now interact. So this box has now also all the labs that I was showing you before included here, ready for you to start them, exploit them, fix them, and all that good stuff. So for example, if I run this one, the runner script, it will say, okay, well, if you do it like this, using the -L, and then we define Java, and let's do the SQL injection lab, for example. What it will do, it's installing a couple of the Java dependencies, and then actually it will boot the SQL injection lab. So as you can see, it's now started. I always like to go to a new desktop so I have a clean screen. Now I click on the browser, and I have a browser interception going on here. And I have a browser, so I can now go to localhost port 7000. And we have the same type of lab new running locally in this environment. And here we can then actually do and exploit and do the lab itself. So let me just show you a bit how we would do it, because I did it so many times already. So we try first with a logical operator. Why that? Because this is, in all the different databases that you have, this is the most consistent thing that's always available. So what we did now, we have a query 2 and 1 is equals to 1. So the content is available, page ID, and 1 equals to 1 is true. So we see the same page coming back. But of course, if we change this logical operator to 2 and make it false, the query, you'll see that we now have an error. So with these two simple injections, I now know that this application and this piece of function is vulnerable for an SQL injection. So that's how easy it is, right? And of course, how are we going to extract now the data? By using a union select. And what is important when you union, similar as a join, the amount of columns from the table need to be aligned, otherwise it can't do the join. Similar with the union select, so I get an error. That means my columns are not aligned, my columns are still not aligned, and now the columns are aligned. So we see the number 2 and 3. Because we had the original data from the page ID is whatever, the title and the content, but now I unioned a new row below, and this application only selects one row, one record, so it selects the latest, and that's why we see number 2 and 3. Now, cool, okay, what do we want as a hacker? We will actually want to see other things like users. Well, there's no table users, cool, we continue, we search for another table name, users, and the error is gone. That means my query is now correct and there's a table users. Now we repeat the same process again with the columns. We have number 2, number 3 here, so that means we can just first do this one. Is there a username? Yes. And then the other one, password, and there we go. So now we selected from the users table actually the admin username and password. Now, is the administrator really awesome and does he have really a big long password like that? Or what do we think? Would be a very good administrator who actually at least picks a very long and type of password. No, so this is actually an MD5 hash. So let me copy this and throw it in the almighty Google. If I am able to copy and paste it. We accept everything. Okay, no, I'm not allowed to do it like that. Paste. And we see that our password cracker, Google, found the password in plain text. And actually, when you look at it, it's a pretty decent password as well, right? It has an uppercase, lowercase, special digit, numbers, 10 characters long. So this one would actually fly through a lot of policies as well. Now, the other issue is it's an MD5. So what is the problem with MD5? Why you shouldn't use it anymore? For security, yes, that's true. Yeah, those are other problems indeed. There's no salting, no stretching, no memory usage for computing and making a cycle. Indeed, there's a hash collision. Thank you. So that means even if I can use a 40 character long, special password, there might be a 6 character password that actually results into the same hash outcome, right? So this is actually, when we talk about security and hashing, this is really the bad thing that can happen, where you have a collision. 2 inputs leading to the same hash output, right? So bonus question, SHA-1, can we use that? Same issue, yes. And the cool thing is, I don't know, 15 years ago, they already prove it in a theoretical way. And then indeed, like, I don't know, 5 years ago, they spent like $3,000 in some cloud computing to make it practical. And again, the world was on fire again. We had to revoke all our certificates because it used this SHA-1 checksum flag and so on. So all this good stuff, you actually find that in the material of the Secure Software Fundamentals, right? So that's the cool thing. You read it there and you can then see it over here in actual practice. Now, the other thing, of course, when we are able to exploit it, we also want to start fixing it, right? So you start your favorite Sublime, or in this case, Visual Studio Code, go to the Java labs, and we go to the SQL injection lab here, and we say, so these are all the labs that we currently have, by the way. You go to open. Yep, you trust the author, because, hey, I'm very trustworthy. And we go to source, main, Java, and here we go. Here we have now the source code, right? Which we now can fix, modify, add our input validation, because that's the first thing you want to do. Minimizing as much as possible the attack surface, right? By whitelisting, lang checking. Some languages you also want to do type checking. And then actually the real implementation using the proper design pattern, right? In this case, parameterized queries. And when you then implemented it, you can use the skills I just demoed, right? Which are also in the write-up to verify your implementation. Now, also the other thing you can do is actually going and starting one of the dynamic application tools. So in here we also have ZAP. Remember, that's a great OWASP project which actually allow you to do dynamic application security testing. So we can use ZAP to then verify if we correctly mitigated the vulnerability. So it's going to boot, load some libraries, load some plugins. Yep. Then we say we want an automated scan. And now it's going to do a spider, scan the application, starting to fuzz the different inputs that it can find, and then give us a result here in the alerts. So passively, it already found that there is no content security policy header available, no anti-click jacking. We're using vulnerable JavaScript libraries. The X content type options is also missing, and we have an information disclosure. So ideally, we want to see here the SQL injection, right? Let's see how far we are. We're almost done. And why do I show you this? Because you will see there will be no issue. There will actually be no SQL injection being flagged here. You see? No SQL injection. Like what? We just saw it was very easy. So what's going on now? So the other important thing is as well, when you use security tools, you also need to configure them, right? And like I mentioned, sometimes they take very long to actually scan the whole application because you need to enable all the options and the features. So for example, in ZAP, what is very important, that when you go to the options and the active scan input, as you can see, it does URL queries, so the parameters with a question mark and that good stuff, but it doesn't do the URL path. And remember, our vulnerability, our input was in the URL path, right? So by default, this is not selected because, look, it says it could slow down testing. So it doesn't mean it's bad, to use dynamic security tooling, testing tools, but yeah, it costs time, more time, and you need to properly configure them for them to be really able to work properly, right? Yeah, so basically you have here a very nice playground with like some DOS tools, SAS tools, all the vulnerable labs that you can start, and you can play in a safe environment. Like you see, it's just here inside the browser. So you also don't need to install anything, or it's just here for you to use. And yeah, there's going to be added way more in the near future as well. So why I wanted to also show you this, because it's actually also part of what we do at ING. Because what we do, we actually build a security champion model and maturity levels. So we have like different levels, the squads the teams can achieve, and the higher you get in the maturity level, the more incentive and speed you actually are getting. So by default, you are going very slow. Oh, you want to release something to production, you need to bypass, some bypass, right? But you need to pass by the security. You need to have a secure code review. You need to have your static code being analyzed, right? And the vulnerabilities that come out. You need to have a change penetration test. So when we talk about DevOps releasing 10 times a day, yeah, that doesn't really fit, right? So we have an option. Follow and implement the security maturity model. So we have it basically on squad level, on persons and in the team. And for requirement level 2, you need to have one security champion, You need to apply the security requirements, etc. Then level 2, we increase what you need to do and what you need to have. For example, in your CI/CD, where you have security tooling running for everything you do, etc. So the more things you do, the more incentive you're going to have. And what we also do is created the same maturity model for the application itself. Because yeah, it's nice that you follow the training, the course, and you're now security aware and all that good stuff. But if you actually don't really practice it and use it in your apps, it's really pointless, right? So we mark it and we measure it as well on squad and team level as on the application level. And for example, if you score like a 4 on your team, but a 2 on your app, then you're actually security maturity level 2. The lowest is what is then valid and the incentives that go with that level. So for example, here we have a couple of cheat sheets that we use inside the company of the different levels they can achieve and which type of incentive they get. And as you can see, with the level 2 and 3, they actually gain a lot of speed. So for teams that want to do a lot of changes, we are not the blocking factor anymore, right? We enable them with security champions, with people who have knowledge about security, to help themselves out and make decisions. And even if you are the highest maturity level 4, yeah, you can even decide when you need a pen test, yes or no, right? That's how much we trust in these champions and of course in all the other requirements that we have defined in the squad and in the app maturity level matrix, right? And also if we look at the results that we have so far, we're doing it now for like almost 3 years, we see that we trained on average like a bit more than 100 engineers, developers per year in the team, in Belgium, for example. And you see that they are now able to release really quickly, but also in a very secure way. And yeah, like I said, if I look at the developers, I really think of the Neos, right? The savior, the one that will save our ass, right? And that's the whole idea of the security knowledge framework, of the whole training platform, that you can make now threats visible, right? You can see them coming because you know how they work, you practice them, and you even know how to defend against it. So the only thing is, of course, right, you need to, like you are here now, so I'm very glad and see that you are here because you chose already in the good way to make that difference and see how deep that rabbit hole will go. And that rabbit hole is pretty deep. But at least everything is self-paced, self-learning in your own speed, and it's free for you to use. And again, we don't want to have the developers like Neo dodging bullets because he's Neo, right? He can just stop bullets. So we want to really push the developers to their full potential and making sure they're ready for the battle. Thank you. This was my presentation. Maybe some questions?
I saw the virtual machine that used the old Ubuntu or something like that. That's part of the SKF?
Yeah, so in the security knowledge framework, we have 2 repos. The app itself with the material and whatnot, and we have the labs. And normally all the labs are basically a very alpine type of image, which then runs or Python, Node.js or whatever for the app itself. Now the other one that I showed you, that is actually an Apache Guacamole implementation, where we installed in this special prepared Docker image, Ubuntu with Zap, with CodeQL, with all the tools that you need and the labs. So yeah, then you can also even run it on itself, right? So you can just go to Docker Hub, you search for the Hackbox, Docker pull, pub, and then it runs. You can also run it locally, only the thing, for example.
So you have 2 flavors. One of the flavors is like you have the public-facing vulnerable website, and the other is a full virtual machine with the same.
Yeah, it's a full Docker image that is available with all the tools installed, or you have the Docker images with the only containing one vulnerable lab. Because, we use those as well in the web API hacking. When we teach there about, hey, you need to test for SQL injection. Well, then we add that tiny little lab and say to the security specialist, the pen tester, okay, now here's this vulnerability, go hack it. So then they don't really need that whole operating system. That's more for the developers, so they can do the offensive, but more important, try to fix it, right? In a safe environment, and then test, okay, did I fix it correctly? So that's why we have two flavors, the labs itself loose on an app, or the whole repo lab in the operating system with all the tools around it. But that's more for you guys, the developers, so you can also actually fix it and get experience with that, right, in a safe environment.
Can I run it locally?
Yes, you can use the Docker Compose up, and it will then spin everything up locally. As this is now running for like 3 months, 4 months online, we didn't push it yet to the main branch. So what is good to notice is currently now, as we speak, you need to use the SOO branch in SKF. Run Docker Compose up, and you have everything. And make sure that you put the context of your Kubernetes cluster on the Docker desktop. Otherwise, it starts deploying labs in one of your Kubernetes clusters, which you don't want because they're vulnerable, right? Yeah. Well, of course, when you search for OWASP SKF, you will find a repository. I had a bit of a brain fart when I created my GitHub account because I wasn't very inspirational. So my GitHub account is blah blah 1337. Here is the repository of the security knowledge framework. So everything I showed you is here included. And then, of course, we have the other one, the labs, and with all the write-ups and the machines and the images, and which you can then also, for example, build your own Docker images or make modifications, etc. That's over here. So the docs, for example, the Java. So here are all the Java labs with all the source code. Yeah.
The test password doesn't work.
The password.
You have on the OWASP website.
Ah, yes.
Test account.
Yeah, that's maybe also good to notice. In the old way, we set it up with a predefined password, but actually now with this new release, we also have the single sign-on. So what you can do is or register an account here in the thing itself, or you can use GitHub or Google to do a single sign-on into it. Because in the future, we also really want to track, what did you do, did you pass it, what not, and even, creating badges and stuff like that where you can show off, like, look how awesome I am because I know my shit, right?
Yeah, but you can check the source code of the whole app, right?
Of course. Yeah, that's the hacking part, but fixing, as you've seen, there are no fixes. Yeah, because you all also know in programming there's like 1,000 ways to do something, right? So, and also I really want to push people to get their hands dirty and try things. Because how I learned doing this is by, not going to school or university or what. No, it's all self, like the building an aimbot. When I was 13, there was no manual how to do that stuff. You just get your hands dirty, right? And I think, this is very good for developers. And I think Zap, for example, that's really a DOST, a dynamic application security scanning tool built for developers. Because you can make recordings, you can add Selenium or Postman scripts into it. You can then, also sequential and follow flows and then fuzz things. I mean, it has a lot of cool, awesome stuff for developers. It's really built for developers, actually. So yeah, some things you can cheat through, others not. But yeah, my most, how you say it, important thing here is that you learn, right? So yeah, there might be people who just want a badge. Okay, fine, they can get it. But other people who actually get the badge, they earn it. And I know these people will build now secure code and secure applications in the future. So yeah.
When building your application, did you encounter vulnerability issues yourself?
Building the application, yes, actually, we had 2 vulnerabilities in it. The first one was in the very earliest stage when we did a sort of uh, 8 years ago. It was in PHP, and I used the MySQL real escape string to prevent SQL injection because I was too lazy to use parameterized queries. And that works pretty okay. But take the page ID example, it's an integer. And you know, in queries, an integer, there's no single quotes around it, so there's nothing to break out of from a hacker point of view, so there's also nothing to escape. So boom, there we had a nice vulnerability. And I think like a year ago, we also had a vulnerability, and that's actually a race condition. So we have this export feature, and when two users would click exactly on the same time, you could the metrics, the results from the other one. Because that's also pretty awesome. That's why we have like 2 different race condition labs now in SKF for the different languages. Because like, that's actually pretty nifty. So we had a race condition in SKF for the exporting of the CSV data. And then we did more research about it, and we found also race conditions could happen for time of check and time of use. So you can have functions that check something, but the function later you're going to use it, so it can pass through the check, even when you have bad, Anyhow, we have cool labs now, so you can check it out yourself and do it. So those were the 2 things that we actually had in SKF as well, So, all right, that was it. Thank you very much.